dear students. Glad to meet you again in this session. In this session, again in this same first chapter, some basic concepts of chemistry in grade 11. Today in this session 1.2, we are going to discuss 7 basic units of SI system. The last session, we have discussed some importance of chemistry and the nature of matter we have discussed, and the classification of matter we have discussed. Students, at the end of this session, you will be able to list some quantitative properties of matter, define 7 SI base units, and you will be able to list some commonly used prefixes. Quantitative properties of matter. In this session, we are going to discuss about the quantitative property of matter. Properties of matter such as area, volume, length are called quantitative properties. Why we call these as a quantitative properties of matter? Because the properties like length, area, volume can be represented by number followed by unit. For example, here look at this rectangular box. It has length, breadth and height, that is width and height, right? Here they have given length equal to 2 meters and width, that is the breadth, is equal to 2 meters and the height is equal to 1 meter. So the length is represented by a number followed by unit. The breadth is represented by the number followed by unit. See, what is the length of this area, this breadth? 2 meters. What is the height? 1 meter. So length is represented by a number followed by unit. The unit of length is meter. Types of measurement. There are two different types of measurements. They are English system and the metric system. We were using these systems in the earlier days. Metric system is originated in France in the late 18th century. In the late 19th century, scientific community need a common standard system and follow International System of Units or SI unit. Nowadays, we are using this SI system. The 7 basic units of SI system are given below. They are length, symbol L, SI unit meter, symbol M. Mass, symbol M, SI unit kilogram, symbol kg. Time, symbol T, SI unit seconds and symbol S. Electric current, symbol I, SI unit ampere and the symbol A. Thermodynamic temperature, symbol T, SI unit Kelvin, symbol K. Amount of substance, symbol N, SI unit mole and the symbol MOL. Luminous intensity, symbol I suffix V, SI unit Candela and the symbol is CD. Apart from these 7 basic units, the other systems like speed, volume, density can be derived from these 7 basic units. Now let us see the definitions of SI basic units of length, mass, time and electricity one by one. Unit of length. The unit of length is meter. First, let us see the definition. The meter is the length of the path traveled by light in vacuum during a time interval of 1 upon 299,792,458 of a second. Consider this area as vacuum. So the meter is the length of the path traveled by light in vacuum during a time interval of 1 upon 299,792,458 of a second. In vacuum, light travels exactly 299,792,458 meter distance in 1 second. So to calculate the time taken, we need to cross multiply. So the time taken T is equal to 1 upon 299,792,458 of a second. So the distance traveled by light during the time interval of 1 upon 299,792,458 of a second is called 1 meter. Next one, unit of mass. The unit of mass is kilogram. Definition. The kilogram is the unit of mass. It is equal to the mass of international prototype of the kilogram. Let us see this in detail. Students, look at this picture. This is a platinum iridium alloy. An alloy is a metal made by the combination of two or more metallic elements. Here, platinum and iridium is combined together, and this is an international prototype. The scientific world has taken this platinum iridium alloy as a standard reference because this platinum iridium alloy is highly resistant material and it won't get attacked easily by any chemicals, and the mass won't change for extremely long period. So that is the reason they have taken the mass of this platinum iridium alloy as a standard one for measuring the kilogram, and that is the unit of mass. The mass of platinum iridium cylinder, it is stored in an airtight jar because just to avoid the interference of the atmosphere. It is stored in an airtight jar at International Bureau of Weights and Measures in Sèvres, France. Unit of time. The unit of time is second. Definition. The second is the duration of 9,192,631,770 periods of the radiation corresponding to the transition between the two hyperfine levels of the ground state of cesium-133 atom. This is the picture of cesium-133 atom. This picture depicts cesium-133 atom. Here in this picture, you could see one electron in the outermost orbit. When this electron oscillates between the two hyperfine levels, you could see the two outermost orbit, right? That is the two hyperfine levels. When this electron oscillates between two hyperfine levels of the ground state, it forms waves. So the time taken to complete one wave is called one period. If this wave completes 9,162,631,770 periods, then that is equal to 1 second, which is the unit of time. Unit of current is ampere. Definition. The ampere is that constant current which, if maintained in two straight parallel conductors of infinite length, means it should have a long length of negligible circular cross section. It should have a considerable cross section, and these two straight parallel conductors should place 1 meter apart in vacuum, would produce between these conductors of force which is equal to 2 into 10 to the power of minus 7 Newton per meter of length. Let us see in detail. This is the pictorial representation to explain ampere. Here we have taken two straight parallel conductors of very long length, right? And it has a negligible cross section. And these two conductors placed 1 meter apart in vacuum. See, look at the right hand thumb rule. The direction of the thumb indicates the direction of flow of electric current in this conductor. Look at the direction of the other fingers. This direction of the other fingers, this represents the direction of the magnetic field when the electric current passes through the conductors. Look at the magnetic field over here. It is pointing downwards. This side it is pointing upwards. When this represents the North Pole and this represents the South Pole, opposite poles attract each other, and due to this attraction it exerts a force, and the value is 2 into 10 to the power of minus 7 Newton. At this time the current flows through the conductors is exactly 1 ampere, which is the unit of current. So we have seen the definition for meter, kilogram, seconds, and amperes. Now we are going to see the definitions for Kelvin, mole, and Candela. And not only that, we will see what is triple point of water and absolute temperature. Unit of thermodynamic temperature is Kelvin. Definition. The Kelvin unit of thermodynamic temperature is the fraction 1 upon 273.16 of the thermodynamic temperature of triple point of water. Before getting into the concept Kelvin, let us see what is absolute zero, absolute temperature, then triple point of water. Then we will go to Kelvin concept. Let us see what is absolute zero temperature and triple point of water. Here we have taken two test elements, gas 1 and gas 2. This graph represents the variation between temperature and pressure for these two gases. Here you could see the curve for first gas and the second gas. If we extend these two curves up to this temperature, it would meet at a point minus 273.15 degrees centigrade, and this is called absolute zero temperature. This absolute zero temperature is called 0 Kelvin. As we move from Kelvin to Celsius, we need to add plus 273.15. Coming to this graph shows the variation between temperature and pressure of water. Here in this graph, we could see three states of water. We could see all the three states exist at a point at which the pressure is 610 Pascal and the temperature is 0.01 degree centigrade. At this temperature and pressure, water exists in all three states. So we call it as a triple point of water. Here, the temperature is 0.01 degree centigrade, which is equal to 273.16 Kelvin. So, what is the Kelvin? It is the fraction of 1 upon 273.16 of the thermodynamic temperature of the triple point of water. So, when we multiply this 273.16 Kelvin by the fraction 1 upon 273.16, we would get 1 Kelvin. That is the unit of thermodynamic temperature. Unit of amount of substance. The unit of amount of substance is mole. Definition. The mole is the amount of substance of a system which contains as many elementary entities. Elementary entities are nothing but atoms, ions, electrons, or some other particles, or any specific group of such particles. So as many elementary particles as there are atoms in 0.012 kilogram of carbon 12. Its symbol is MOL. Let us see why they have taken carbon 12 as an arbitrary one. We could easily count the number of bigger objects, but when we come to the microscopic particles like atoms and molecules, it is very difficult to count them. That is why scientists have taken carbon 12 as the reference to define mole. Why they have taken carbon 12? Because carbon 12 has 6 protons and 6 neutrons, which is responsible for mass. C12 isotope is present 99.98% in nature. Most of the compound available in nature contains carbon. Moreover, carbon is in the solid form and it exists as atom. So they have taken carbon 12 as an arbitrary one. The amount of substance present in 0.012 kilogram of carbon 12 is called 1 mole. How much amount of substance present in 1 mole? In 1 mole we have 6.022 into 10 to the power of 23 elementary entities. Whatever may be the substance, whether it may be carbon or hydrogen or oxygen or chlorine, 1 mole contains 6.022 into 10 to the power of 23 elementary entities, and this is called 1 mole. Unit of luminous intensity. The unit of luminous intensity is Candela. Definition. First, let us see the definition for candela, then we'll see the explanation. The candela is the luminous intensity in a given direction of a source that emits monochromatic radiation of frequency 540 into 10 to the power of 12 hertz, and that has a radiant intensity in that direction of 1 upon 683 watts per steradian. Luminous means light emitting object or source. Intensity, in a simple way, we could explain it as the brightness of the light. When we switch on a 0 watt bulb, the light intensity will be very dim. When we switch on a 50 watts bulb, it will be very bright. So that is the intensity. So we know that different colors of light have different frequencies and wavelength. We consider a monochromatic source. Mono means single, chromatic means color. Single color light or single wavelength source of light of frequency 540 into 10 to the power of 12 hertz, and consider an area covered by that light has a solid angle of 1 steradian. Steradian means area upon square of radius, and this area has the radiant intensity of exactly 1 upon 683 watts. Radiant intensity means that much of power, that is energy per unit time. And that area, that radiant intensity of exactly 1 upon 683 watt, then the luminous intensity of that light, monochromatic light, is called candela, and that candela is the unit of luminous intensity. Now, in the SI system, this SI system allows us to use prefix to indicate the multiples or submultiples of a unit. For example, these some of the prefixes are very familiar, like nano, micro, milli, centi. These are all very familiar prefixes, and some of the prefixes like kilo, mega, giga, hecta, hecto, deca, these are also very familiar to us. So the SI system allows us to use prefixes like this to indicate the multiples and submultiples of the units. Now, students, let's recall what we have discussed in this session. We have discussed the base physical quantities and their units, symbols also we have discussed. We have discussed the definitions for SI base units, meter, kilogram, seconds, ampere, Kelvin, mole, and candela. We have discussed the prefixes used in the SI system. Hope this session is very useful to you. See you soon in the next session. Have a nice day. Thank you.